After this lesson, students will be able to translate from verbal to algebraic expressions. Do now pause the screen as you answer these questions and restart the video when you're ready. Number 1 matches with C. What number minus 3 gives 9? Number 2 matches with A. 3 times what number gives 9? And number 3 matches with B. 9 minus what number gives 3? Math makes magic. We're going to do a little magic trick. Think of a number, and don't forget what your number is. You may want to choose a number on the smaller side since you'll have to do some mental computation. Add 7. Multiply by 5. Subtract 5. Divide by 5. Subtract your original number. Add 4. Subtract 3. 7. I knew your answer was 7 because I was using algebra. When I asked you to think of a number, that's an unknown number to me, so I used a variable, n. When you added 7, I was thinking n plus 7. To multiply by 5, I had to distribute. So you get 5n plus 35. When you subtract 5, you can only combine like terms when adding and subtracting, so you end up with 5n plus 30. Dividing by 5, I can divide by both terms, so I'm left with n plus 6. When I asked you to subtract your original number, we subtracted n, which left all of us with 6. At this point, I could have guessed your number was 6, but decided to continue the fun and had you add 4 and subtract 3, so we all got 7. I used n to represent an unknown number. A variable is a letter that represents an unknown or changing number. An algebraic expression is a statement that includes numbers, variables, and operations. You may be familiar with the word operations from the term order of operations, which relates to the adding, subtracting, multiplying, and dividing. For an algebraic expression, there is no equal sign. If there was an equal sign, it would be called an algebraic equation. Some examples of algebraic expressions are 3b plus 2, 25d divided by 5, 8 plus x, and 16 divided by y, which all have numbers, variables, and operations without an equal sign. Different ways of representing multiplication in algebra include a number right next to the variable, a dot or asterisk in between the two quantities, next to the parentheses. So if you ever see a problem where you've got 5 and then in parentheses 4, you'll know that that means multiplication and the answer would be 20. Different ways to represent division in algebra are with the division symbol, or more commonly, like a fraction. Now we're going to practice translating from verbal to algebraic phrases. Translating from English phrases to algebraic phrases, which include numbers, operations, and variables, is like translating between languages. So, dictionary, a buzzword cheat sheet. This includes different words that represent different operations like addition, subtraction, multiplication, division, when you raise something to a power or have something grouped in parentheses. There are also words that signal when something would be equal to or less than, greater than, etc. So take the time to look at this list and study ones that you may not be familiar with. Especially important to note are the ones in asterisks. More than, less than, have asterisks because you're going to write those in the opposite order. Keep that in mind as we do the following problem. Write an algebraic expression for each phrase. Part A, 5 more than n. More than is a buzzword for addition. It did have an asterisk, which means that we have to change the order. So while 5 comes first in this verbal expression, first in my algebraic expression. Part B, the sum of n and 5. This one doesn't have an asterisk and represents addition, so I'm going to do n plus 5. Keep it in the same order. Part C, the difference of n and 5 is subtraction. Keep it in the same order. 5 less than n, less than had an asterisk, so n minus 5. E, the product of 5 and n, would be 5 times n, which we can just write as 5n. And F, the quotient of n and 5, so n divided by 5, which I wrote like a fraction. Sometimes we need to first define our variable. So in part A, 3 times a number plus 8, when they said a number, they didn't tell us which variable to use. So to show that we're being thoughtful about our choice in variables, we need to define it. Let x equal the unknown number. At this point, I can use x instead of that unknown number and say 3x plus 8. Part B, 10 less than 4 times a number. Less than is subtraction. I also have to remember to switch the order. And times a number, so I'm going to be doing multiplication. Let x equal the unknown number. I have 4 times my number, and I'm taking 10 less than that. Translating verbal sentences to algebraic equations. Hint, these usually have the word is or equals. For example, part A, 2 more than a number x is 10. So I have more than, which is addition with the change in order, and is, which stands for equals. So x was defined for me in the question, so I've got x plus 2 equals 10. Part B, the difference of a number A and 2 is 7. Difference is subtraction, is means equals, so A minus 2 equals 7. C, 12 is less than 6 times a number x. Is less than, which has a subtle difference than just less than, represents the inequality symbol, not subtraction. So 12 is less than 6 times a number x. In part D, 8 more than a number y is greater than or equal to 9. More than is addition with the change in order, and is greater than or equal to is the inequality symbol. So we've got y plus 8 is greater than or equal to 9. Challenge questions. Pause the screen if you'd like to try these on your own and resume when you're ready. 2 more than the product of 10 and a number. Well, on this slide, since the variables are not defined for us, I'm going to say that let x equal the unknown number, and we'll say that that's true for all 4 of these questions. More than is addition, product is multiplication, so I take the product of 10 and a number, and I'm adding 2 to that. The sum of a number and 1 times 3. Well, the sum of means addition, and then I'm multiplying. Now, normally, with order of operations, we would multiply first and then add. But because of the comma, we want to actually add the number and 1 first and then multiply that by 3. So x plus 1 has to be in parentheses, and then I can multiply that quantity by 3. The difference of a number and 6 divided by 2. The difference of a number and 6 would be x minus 6, and that entire quantity is divided by 2. So I can write it as a fraction like this, in which case we would simplify the numerator first, and then the denominator, and then divide next. 3 less than, the product of 6 and a number is 9. Less than, in this case, is subtraction with the change in order. The product of 6 and a number, and is, those are our buzzwords. So I'm starting with the product of 6 and a number, so I'm consistent with order of operations. I'm taking 3 less than that. Notice how I changed the order because of less than. And the answer is 9. Math Flash. Write your answer down on your paper. So pause each screen after I go, and then you can check it when you're ready. 3 more than a number. Let x equal a number. And we'll say that that's true for all the following slides, so I don't have to write this on every slide. X plus 3 would be the answer. The sum of a number and 1, x plus 1. Difference of 8 and a number, 8 minus x. 6 times a given number, 6x. The quotient of a number and 5, x divided by 5. 1/2 of a given, 1/2 x. The of means times. 7 more than twice a given number, 2x plus 7. The sum of a number and 6 divided by 2, x plus 6 divided 11 minus a number b is 2. 11 minus b equals 2. 8 more than a number y is greater than or equal to 9. Y plus 8 is greater than or equal to 9.